From ChemSec, we have Dr. Holmquist. She will talk about the importance of remove PFAS before it enters into the products. So it means that when you design things, you need to be without PFAS, and the importance of having legislators to make sure that we have a total ban on PFAS.
Thank you, and thank you for that nice introduction. So my talk is termed PFAS do not belong in circular material flows. And I will start by telling you a bit about ChemSec, because maybe many of you in the audience do not know what we do. So ChemSec is an environmental NGO. We aim to reduce the use of hazardous substances, and we have a strong focus on PFAS. We cooperate with different stakeholders to drive this change to safer chemicals. So this is why I'm here, for example, to talk with you and learn from you and teach you hopefully a bit about PFAS and how we can get rid of them. And we do this with funding from the Swedish government and from various charity funds. And how do we do this? What work do we do? We're 12 people at ChemSec, so we are a little organization, but I think we have quite a lot of effect out in society. We drive political discussion on hazardous chemicals, so we are involved in the EU mainly, in the discussion setting the regulatory framework on hazardous substances. We challenge companies to improve their chemicals management, but we also help companies to improve their chemicals management by developing online tools. So you will see a few examples with focus on PFAS in a bit. And we inform investors about risks and opportunity in the chemical industry, because it's of course money that drives our society. So we need to work on where the money is. And my co-presenters here, they concluded in the end, but I want to give you my 3 main arguments up front. So this is what you will hear about. You can stop listening now after this slide, if you like. My message, my first and most important message, is that we must turn off the tap. We have to stop using PFAS, because the problem will only grow if we continue using these substances. The good thing is that we can turn off the tap. We have alternatives available, so we can do a substitution. We can reduce the amount of PFAS in use and the amount of PFAS emitted. And for this theme, for this talk here, circular economy could threaten an effective phase out if we are not careful when we do this introduction to a circular economy. And I will address some of these issues here. I'm a toxicologist, so I will go into, what are PFAS and why should we be very careful with the PFAS. I'm not an engineer, so I will not give you the actual answers on how to solve this circular economy technological challenges, but I think other people will cover that. So I think this is what I got when I was asked to talk here. PFAS are everywhere. What can we do about them? And they are everywhere, but maybe backing a bit, what are PFAS? Well, we have a restriction proposal. I will talk a bit more about it in a bit. That proposal is said to cover about 10,000 chemicals that belong to the PFAS family. So it is a family of substances that are fluorinated. These are PFAS. You might recognize some of them, or maybe here. So you have PFOA, you have PFOS. They are the C8. Examples of the C8 PFAS that are well known. Many people have studied them. There have been a number of different definitions of what is a PFAS, but the current definition is it's a fluorinated substance with either a fully fluorinated methylene group or a fully fluorinated methane group, with a few exceptions if there are halogens exactly onto this very single carbon atom. So the thing is that many, many, many chemicals are PFAS, and that's good to know when we continue this talk. They are also used in many different products. So this is a statement from Juliane Glig and her co-authors. So she's a researcher at ETH in Zurich. So they state that PFAS are used in almost all industry branches and many consumer products. And they cover this in this excellent paper that has been used in many, many discussions and in many regulatory processes. They list in the end of the paper uses that they prioritize to look into further and see can we phase out PFAS. So they are firefighting foams, polymerization agents, surface protections for textile, for example, this carpet, I don't know, maybe there is PFAS here, electronic devices, machinery, fluoropolymers in plastic, rubber, coating, paints, varnishes. So it's everywhere in society. And are the big numbers then? So they are many, the PFAS, but are they used in big quantities? Well, in this restriction proposal that I will come back to in a bit, they quantified use and emissions of PFAS. It's of course a lot of uncertainty around these numbers because there are so many substances, but they estimated the annual use in the EU in 2020 to be 840,000 tons, with emissions created from this use of 75,000 tons. And the more worrying fact is that if we estimate emissions in the future in 2050, these would be 4.4 million tons of PFAS. But maybe we have a problem already now. So this map is from the project, the Forever Pollution Project. So a number of journalists went together to map out the PFAS problem. And the headings are from The Guardian, or maybe you can't even see it, revealed scale of forever chemical pollution across UK and the Europe. So what you see here, the red dots are known contamination sites, many red dots. The blue dots are presumptive contamination sites, because maybe we haven't measured everywhere, right? But with the knowledge of what uses we have, we can assume that we have contamination. The black dots are not even visible because we have so many contamination sites, right? But they are the manufacturing facilities. So the scale of the problem is large. And so is it then a problem? We have it in the environment, but will anything happen? Well, I will come into that. There is new threshold values for when we can expect that PFAS could have negative effects on human health and also on the ecosystem. So Matt mentioned that they have changed over time when we learn more. So the European Food Agency new guidance value, it's 6.9 when converted into blood levels. It has been so much lowered over the last 20 years or even 10 years for PFAS and PFOA, and now it's broadened to include more and more chemicals as we learn more. And that value is based on immunological effects. So if we have this level in our blood, if you breastfeed your baby, you risk giving immunological effect to your child, for example. Well, at ChemSec, we tested our blood. And at ChemSec, we sit in our office. We're not highly exposed to PFAS like people who would work in a manufacturing factory. Still, all ChemSecers had PFAS in their blood. And some of them even had it above this limit value of 6.9. So I think you're convinced already that PFAS is a problem, right? The main concern is the persistence, because this gives us this circulation of the PFAS in environment, and we are exposed and it accumulates. So even if emissions continue and do not increase, the environmental levels will increase because the PFAS cannot be removed. Some PFAS are not highly persistent, but then they degrade to other PFASs that are persistent. So in the end, we have a problem. Many of them are mobile. They move around. So if you have an emission in one site, you will find them in another. For example, in the groundwaters that we use for drinking waters. Other are bioaccumulative. So levels increase in the trophic ecosystem trophic chains. And we get higher exposure higher up in the chain. And 10,000 chemicals, or even if you look in the PubChem database, 6 million chemicals are identified to belong to the PFAS group. So of course they have different properties, but some of them have been shown to be toxic to humans, immunological effects, effects on the liver, reprotoxic effects, cancer effects. So it's many types of effects. Some have been shown to be toxic to other organisms in our environment. Some have shown to have endocrine activity, so they affect the hormone system. Some accumulate in plants, others accumulate in humans, and many have long-range transport potential. So I think you're already with me here, that this is a problem and we need to do something about it. ChemSec put a paper out last year where we calculated the societal cost of PFAS to be 16 trillion euros. That would include the cost to remediate contaminated sites, the cost for PFAS-related health issues that the hospitals need to take care of, etc. And if you compare that with the revenue, the win that the companies make, it's a big difference. So we calculated the PFAS revenue per year to be 26 billion euros, a much smaller number. And the chances are, of course, that the societal cost is underestimated here, because that's, of course, a very tricky number to get hold of. So there is a reason to act, right? And it's bound to be quite difficult. What is society doing? Maybe we're doing something already now. Yes, we are. A lot of things are happening, and we should be very happy about that and proud, but we need to do more. Some examples first from what ChemSec is doing to support this phase out. For example, one of the tools I mentioned, we have tools on our website, we have a PFAS guide, because with 10,000 chemicals in many, many different uses, if you are a producer and you want to phase it out, it can be difficult to know, where do I find the PFAS? How do I know if I have PFAS in my materials? The PFAS guide can support you to show products likely to contain PFAS chemicals and give advice on how to phase these out. ChemSec also run the PFAS movement, where we have more than 100 members. And the companies that have joined the movement, they recognize that PFAS is a major health and environmental problem. And they support a group ban on all non-essential PFAS uses. And they have the ambition to do this phase out in their products and supply chains. And many of them have already. So that can be seen as an inspiration, and also there are many learnings to be made from their work. And my dearest tool is the SIN list. So I'm responsible for the SIN list at ChemSec at the moment. And the SIN list is a phase-out list. So if you know the EU chemicals regulation, you know we have the candidate list. On the candidate list, we have the substances of very high concern. These should be phased out and not be in use unless essential, basically. But the candidate list has been around for a long time, and still it's only a few hundred substances on there. So it's a good process, but it's a slow process to put a substance on the candidate list. With the SIN list, we want to accelerate this. So we use the very same criteria for when a substance is a substance of very high concern as for the candidate list, but we work quicker. So on our list, we have 1,400 plus substances at the moment, and it is continuously growing. So the idea is that the SIN list is a tool for the companies who want to be proactive. They don't just want to find what substances are banned or regulated now, but what substances should we remove to be ahead of regulation. And we see proof all the time that substances are being put on the candidate list, but we put them on the SIN list in 2008 or 2015. And we also use it, of course, to put pressure on legislators to move forward with speed and urgency. So have a look at the SIN list. It's available on our website. So that was some slides on what we do at ChemSec. And of course, there are other actors, and very important, the EU is, of course, having a chemical regulation, or many chemical regulations in place on PFAS. So what you see here is a simple graph where we have on the y-axis the coverage of PFAS by the different regulations. And then on the x-axis, you have, where in the decision-making process do we have this restriction or ban. So you have the universal PFAS ban. That was already mentioned by Per, I think. So there are a number of member states who've proposed a ban to, proposed a restriction to get all these 10,000 PFASs out from society. So that is under discussion with ECHA at the moment. So the proposal is available for you guys to find on the web and read, and it is being discussed by the Risk Assessment Committee and the Social and Economic Assessment Committee So we will see what the end product will be, but the idea is that we will get all the PFAS out, and that only when there are no alternatives, there will be a derogation from this ban, and that will be time set. This is the ChemSec message, and then we will see how the ban comes out. But now we have already a number of PFAS regulations in place. So you see on the right-hand side, the PFAS and PFOA, and the C6, the perfluorinated hexanoic sulfonic acid, they are already in the Stockholm Convention, so they are globally banned. And also not only these three, but also substances that can become these PFAS if they degrade. We have TDFA, which is also has a ban in place. We have the longer chain alkylated acids. They are the one called C9 to C14. They are restricted in the EU, and a ban under the Stockholm Convention is underway. We have a very new decision on the C6 carboxylic acid, the PFEXA here, to be restricted in certain uses, for example, textiles. And the FFF is firefighting foams. So a ban is underway also there. But you see, this will be fragmented, and we will have a lot of PFAS falling in between here that do not belong to the PFEXA category or the PFOS category, but they are still a PFAS. So that's the idea with the universal ban, that you would cover everything. Other relevant policies, of course, several PFAS are substances of very high concern, identified as such, meaning that they have to be reported in the SCIP database, the database with waste materials. We have a new packaging and packaging waste regulation stipulating that we cannot have PFAS in food containers, for example. We have a toys directive coming up stipulating that we cannot have PFAS in toys. And there are a lot of limit values in water and food coming into place for PFAS, for a few that are already in place for PFOS, for PFOA, and they are being widened to encompass more types of PFAS. Things are, of course, also happening globally. So, for example, in the US, we have 34 states that have introduced 292 PFAS policies. In the US, they have a framework for addressing new PFAS and new uses of PFAS under the Toxic Substances Control Act. There are several other things happening in the US. In Australia, they have a PFAS National Environmental Management Plan and other actions happening. Also, China are discussing PFAS, Japan. So it's a global issue and it's globally recognized. So a lot on the problems and the bans, but are there alternatives? Yes, there are alternatives. On our site, Marketplace, that's a business-to-business marketplace where we intend to show that there are alternatives for hazardous substances available, but also facilitating contact for the companies looking for alternatives. At the moment, we have 109 results when you search for PFAS alternatives, but we are adding more and more alternatives all the time. In the universal PFAS restriction proposal, they have found alternatives for most uses. So a substitution seems very feasible. There are, of course, a few uses where there are no alternatives. For example, in personal protection equipment, in medical devices, and those might take longer to resolve. But our message is, of course, that only essential uses of PFAS should be allowed to continue, for example, in medical devices. But also we need to empower research to find alternatives, to not settle down here and just say there are no alternatives. If we have research in place, there will be alternatives. We're quite convinced in due time. And policy needs to support this research and to support the market of the new alternatives. So this is another way of showing what alternatives are available. On the x-axis, you have the availability of viable, safer alternatives to PFAS. And on the y-axis, you have the volume of PFAS per sector. So this is very much based on the restriction proposal. So on the high volume, we have F-gas applications, so fluorinated gases, transportation application, too lucky is textile and leather and these kind of things, food contact material, construction products. And luckily, It's high volume, but we also have a lot of alternatives available. So it will be effective. On medical devices, a lot of research is ongoing, so we have new solutions coming up. A lot of PFAS are used today in very specific applications, but we see new types of polymers coming in, being possible to replace the fluoropolymers. We have some things that are already sold, luckily. So in cosmetics, we have gotten rid of a lot of PFAS or are on the way in ski waxes, consumer mixtures, chemical products that we as consumers use. And then we have challenges, for example, for electronics and semiconductors and in the energy sector. So do PFAS pose a risk to the circular transition? First, and I think my main message, PFAS in circulation is not part of a sustainable development. So that's the core of my message and the baseline. And then we saw a pile of waste again, and when we have circularity, this is textile waste in big chunks, balar in Swedish, and you see it's a mixture. It's different materials, it's different colors. They have been used probably for many different things, and some of them might contain PFAS because we have them in textile to get the textile water and oil repellent. And PFAS can be a barrier to the circular transition. If we want to effectively phase out products that contain PFAS, then these products might be given a shorter life length or shorter circulation in society than otherwise possible. So then we will reduce the effect of the circular economy in a sense. But on the other hand, the circular transition, if we do not take care of the PFAS issue, can be a barrier to an effective PFAS phase out. So if we keep the phase out in the PFAS in the loop, they will continue emitting. So you remember the 840,000 tons of PFAS in use, they created an emission of 75,000 tons of PFAS per year. So when we have them in use, they create an emission, right? So we should not have them in use. We have to turn off the tap, but we also have to be careful with what we do with the stock we have in society already. And collection and destruction is part of the answer, right? So we have to identify where we have PFAS. And on the analytical side, there are more and more methods coming along where we can search for total organic fluorine, etc. So we can see any PFAS that is in the material. It's not that simple, but I mean, it's at least methods are coming, right, to cover these 10,000 PFASs. So we can find them. Which of these textile heaps can we reuse and which should we destroy? But also we need to think about destruction, that we do not just move PFAS from one place to another. Incineration sounds like the final solution. There's a big risk that when we incinerate, we just change the PFAS. So we have one PFAS coming in and another PFAS coming out. So we have to be very careful. If we clean water with activated carbon, many PFAS will stuck. But how do you then treat the activated carbon to get them out of circulation? So at ChemSec, we work with recycling companies, and I selected a quote here to establish this fact that we need quality and not quantity in our circular flows. So it's Cedric Lechat at SARP Industries saying that there is a need for incentives that encourage the quality of recycling, not the quantity. And I think for PFAS specifically and hazardous chemicals in general, we need to think about that. Maybe it's a transition period now. If we get very efficient chemicals regulation in place and we have a society free of hazardous chemicals, then we can have the large volumes. But at the moment, we have a lot of hazardous chemicals in stock in society, and we need to be careful with what flows we create. And of course, I think it's been mentioned already before, but plan for the waste treatment already in the design phase of products. That's one of the keys to avoid hazardous chemicals. So you see this meme when he tries to read the list, the very small list of recycled materials that this person can use because he has a high standard on the quality of the flow. So we have a lot to do here. And that was the end of my talk, and I have no idea of time, but stay in touch with us at ChemSec. You see the website and contact information, and thank you for listening.
Well, you're very timely. You say that, well, now we are removing PFAS and they have found other ways. Is there a risk that we are creating a new PFAS scandal? Well, now we talk about, you remember we had a problem with DDT and PCB before. So the question is there a risk that something else will come around the corner in 20 years from now?
Hopefully not, because hopefully we are learning. But I think there needs to be this story to be told that we knew, society and especially industry knew about the hazards of PFAS a very long time ago, but no one acted. And now we're slowly waking up and doing the right things, but it's going way too slow. So the thing is, like, when we get these evidence, I mean, I think the first evidence of PFAS toxicity was in the 70s. And before, in the 90s, we discovered PFAS in people's blood. And then the phase out started in the 2000 and onwards. And now it's 2024, and we're still not there. So that's, I think, of course, there is a risk. We went from the chlorinated, and we were scared of them, and then to the brominated, and we were scared of them, and now we are on the fluorinated, and we are scared of them. And I have no idea what's coming next. Matt is going to find out for us, right? But just to learn a lesson here, to act sooner. Ideally to avoid them, but to act sooner when we learn about the problem.
But it sounds like we have a big cleanup project ahead of us.
Definitely.
And don't use activated carbon. What's that your...
No, I think activated carbon can be used, but be aware that then you just collect the PFAS, right? And you have to be very, very thoughtful how you treat the activated carbon, because it's being reused, right? You don't just put it in a landfill, you reactivate it by heating it up. And you need to do that in a way, not just move the PFAS around, to remove them from the carbon and not create an emission at that site.
One of the later presentations will demonstrate the technology that in another way can collect the PFAS. So let's come back to that, and we can reflect on that in the panel discussion.
Yes.
Thank you so much, Hanna, for this. And now we have really deep diving into the secret of the challenge that we're facing to create circularity. Hopefully we can now start moving into, okay, how can we still have a circular transformation? So by that, thank you.
Thank you.